Hi, Introduction to LabVIEW. LabVIEW is Laboratory Virtual Instrument Engineering Workbench. That means it is like an instrument for an engineer. You can see the outside of an instrument and you can work on the inside of the instrument. It is a graphical user interface language. You drag the blocks into the block diagram or on the front panel, connect it through wires and run the program. The learning outcome of this particular presentation is, after going through this presentation, the learner will be able to understand front panels, block diagrams and connectors and icons, use the programming structures and data types that exist in LabVIEW, use various editing and debugging techniques. The contents are LabVIEW environment, front panel, block diagram, data flow programming, LabVIEW help and manuals, debugging API. When you launch a LabVIEW, this is the screen you are getting on your computer. Again, go to Launch LabVIEW. You will get a LabVIEW environment where you get the dialog box, LabVIEW programs. LabVIEW programs are known as virtual instruments, that is VI programs. Open a new VI from the file. You will get front panel and block diagram. The front panel, you give controls and indicators. Controls means inputs and indicators are outputs. So front panel is the place where the user puts the data and takes the data, whereas block diagram is the place where the programmer or the designer designs the instrument or the program. So this is a particular LabVIEW environment where you have block diagram and front panel. You can see that in the front panel you have the values. Two programs are there on the block diagram. One is to add two numbers and the other is to AND two Boolean quantities. Now it is after running, the values are put and you are having the output. For the sum, you have the inputs as 5 and 10 and you are getting a sum as 15, whereas in the AND function, the inputs are 1 and 1, so the LED is glowing. You can have different properties for your inputs, outputs, different shapes. If you want a push button as your switches, you can have it. If you want a long LED as or round LED, rectangular LED, you can have any of that side. With red color as output 0 and green color as output 1, you can have the different colors for LED. The icon is the graphical representation of a VI and it is mainly used when you are doing with subprograms or sub-VIs. Even connector you will do at that time. So the controls and indicators, you can have numeric control, Boolean control or graphical. Same way with numerical indicator, Boolean indicator, graphical indicator. And coming to functions and programming, as in any other structured language, you have for loop, while loop, case statement. So for loop will have the maximum iteration I. Same way for a while loop, the condition is there when to stop the while loop and the iteration. For case statement, normal case statement is either true or false. You can have it like a switch statement with 1, 2, 3, 4 conditions. So that many blocks will be there. Troubleshooting and debugging. So you have, when you see the LabVIEW help utilities, you have show context help, which is a very fantastic tools in LabVIEW. Open the show context help always and take your cursor to any of the block. It gives the complete details of that block. Also you have LabVIEW help for in general or NI examples where you get examples connected with your field. So you can see in this slide a Boolean indicator is connected to a Boolean control, which is not allowed. So you get a broken wires and even the run command is broken. That shows, and when you double click at the run command, it gives the list the errors. So this is another example of wrong input. The numerical addition expects a numerical control here, and I have given a Boolean control, so obviously it is a wrong data in. The wires are broken and the running command is in a broken manner. If I change it, I will get. Now again, I can see the values whilst running the program by putting the highlight button on. This is the highlight button. If I put the highlight button on, I get the values as shown in this. It will run, it will show the values and then do. This is more needed when you are using loops and all. If for checking for logical errors, this is very much needed. You can have a breakpoint in a for loop or a while loop or with conditions. Or you can have probes to check the values, what value at that point on the wire. You can have probes. Now for front panel design, right now in this presentation I am using only the first one in input and first one in output data, that is manipulating controls and displaying with indicators. You can read directly from a file or output to a file, receiving from a device and output to a device. The fantastic part of National Instruments LabVIEW is National Instruments having some hardwares for doing your analog and digital input data and manipulating it or storing it, displaying it, etc. So that case I can receive the data from a device or output to a device. And front panel, when I have taken, it was in a very shabby manner by putting all those things somewhere. You can have decorations to make it very neat by putting one panel here, all the inputs on that and outputs on that, so that it will be very beautiful to see. So these are some of the objects for decoration. As per your design you can put. Now the different data types are floating point numbers, it is in orange color, integers blue, boolean green, and text is in pink. One more data type, a new data type, that is cluster, which are multivariables. They contain one or more elements of different data types. The difference between array is a collection of data of same data type, but I can have different data types in cluster. Numeric data types, you can have different representation. When I take floating point, 32-bit, 64-bit, all those things are there. And in Boolean also I can have different switches, different mechanical actions, switch when released, latch when released, all those things. Go to the LabVIEW platform and see all these things. Now while loop can have stop if true or continue if true. the tunnel transfers the data outside. So it is having two LEDs alternately on and off with a slide. When in the running portion itself, I can change the slide value so that the slide is connected to a delay. So the delay will be increased. The difference in on and off period will be controlled by this slide. This you can see that I have put all the inputs and outputs on a decoration. And now for loop, I can have the maximum iteration I. It is an example of sum equal to sum plus I. And if I want to break, I can give the condition inside the for loop. Then you will experience a red dot in the box of n. The case statement. Both the conditions you have to give in true or false. This is a program I have done for the square root of a positive number. If a negative number is given, it will print something ASDA or something and a number 99990. Now one example, data transfer using shift register. So I want to multiply the previous product with the current number, current iteration. So my for loop n varying from 0 to n minus 1. So for one is for sum and another is for multiplication. I cannot start with the first iteration 0 for multiplication because always it will be 0. So I have initiated it to 1. Here it is sum equal to sum plus 2. Always it will add sum equal to sum plus 2. Here it is multiplication will be product equal to product into 1. So again I have kept one question for you. Please note down the question and try to do it in a LabVIEW platform. The one I have initiated it to 0. So after first run what should be the output, and after second run of this what should be the output. Here I have initiated it to 2. So after first run what should be the output, and after second run what should be the output. Please try it yourself on a LabVIEW platform. So I can have a stacked register also. So this is average of last 5 random numbers. You will require it for moving average and all. So the last 5 average random numbers initialized to 0. So each time the previous one will be added. I have given a delay. Now plotting. You have graphs as waveform chart, waveform graph and XY plot. In waveform chart, each data is taken and printed like your CRO. In waveform graph, the complete data is collected and printed. Whereas in XY, X versus Y is plotted. Thank you.